Hello, in this video we want to talk about meteors and meteorites. To get us started, we can answer the question, what is a meteor? It's just any piece of debris that enters the atmosphere and is large enough and moving fast enough that it creates this fiery trail behind it. Um, it's going fast enough that the friction of the air passing by it superheats all the gases in the air, and you end up with this flaming trail behind it, which actually burns away some of the material of the meteor as it's going. Uh, these are more commonly called shooting stars. But obviously, they aren't actual stars. They have nothing to do with the stars. They're just any piece of debris that can enter the atmosphere and create this trail of superheated gas and disintegrating material. And a little bit more realistic depiction of it as opposed to that one. Okay, this is more what it actually looks like seeing one from Earth. Probably all heard about wishing upon a shooting star. Okay, kind of makes it sound like they're rare. There's actually estimated to be about 25 million of these meteors that are bright enough to be visible every single day. So you might expect it should look something like this, but there's a few limiting factors. Okay, you have to be within 125 miles of where it enters the atmosphere to be able to see it, for one thing. So that really limits the number that we see. And also, obviously, you can only see them at night, right? So you have to be in a dark place, and even moonlight is enough to overshadow most of these. Okay, so you have to be viewing them at night and in a place with no ambient light and a night where there's no or very little moonlight. Okay, so often we can only see one at a time. However, if the conditions are right, with that many happening every day, it's not uncommon to be able to see up to 6 per hour if you have the right lighting conditions, kind of no matter where you are on Earth. The material that comes into the atmosphere and becomes a meteor is usually left over from either passing comets or asteroid fragments, or even material that's been dislodged from other planets and moons. Okay, from meteorite strikes. You can dislodge material, which then gets disintegrated and floats around until we cross paths with it. We've all heard of meteor showers. Okay, they're a little bit more rare than meteors, and what this is where you've got lots and lots of meteors coming in at once or over a short period of time. A lot of times you can't actually see this many at once. This would be like exposed photography where you can see all of the meteors that have happened over a certain period of time. But during a meteor shower, the Earth is usually passing the trail of a comet. Okay, and from previous videos, you know that the comet is got a lot of ice in it, and as it comes into the inner solar system, a lot of that vaporizes and leaves this trail of dust and ice and debris behind. And so when the Earth passes through that trail, we get these meteor showers where we have lots and lots of meteors over a short period of time. They're usually very predictable as far as when we're going to see them, just because historically we've been able to map out when we're going to cross paths with these comet trails, and a lot of times they're named for the constellation that is in the same line of sight as where the meteor shower is going to happen. You can see from this picture, all of these meteors appear to be coming from a single point. That point is just called the radiant. That's the point where the Earth's atmosphere intersects with this comet trail, and obviously they're coming towards us, so they appear to diverge a little bit, kind of like looking down railroad tracks. The tracks kind of diverge from that vanishing point. Same thing happens with the radiant, just in kind of all directions. Okay, moving on to talk about what meteorites are. So a meteor is just like we said, any piece that enters the atmosphere, a piece of debris that enters the atmosphere and creates this visible light trail. Well, meteorite is when one of those meteors survives all the way through the atmosphere and lands on the surface of the Earth. Okay, so that's the big difference between a meteor and a meteorite. Meteor doesn't necessarily make it all the way to the surface. Most of them, in fact, either burn up or disintegrate before they reach the surface. We do get several thousand meteors that survive to become meteorites every year, so there's several meteorite falls every day. But that is a vast difference from 25 million meteors that we saw before. Now there's only several thousand per year, and that was 25 million per day that we were talking about a little bit ago for meteors. So meteorites are comparatively rare to meteors. Most of them don't survive. Um, and so obviously the larger it is, the better chance it has of making it to the surface. Okay, small meteors tend to completely burn up in their passage, and larger ones tend to only have some of it burn up, and the rest makes it to the surface. Also, if you have two that are the same size and are large enough to make it to the surface, if one of them is going faster, it's going to have a lot more friction, and a lot more of it is going to burn up. And so the faster it goes and the smaller it is, the less likely it is to make it to the surface, whereas larger or slower moving fragments will tend to survive. Okay. And they can range in size anywhere from teeny tiny to absolutely huge. Okay. And these meteorites that make it to the surface, sometimes they are just the remaining piece of whatever the meteor was, and sometimes a meteor will break up into several meteorites. Okay. So a larger piece will break up into many smaller ones that then make it to the surface, which is where we get a meteor shower. Okay. Different from a meteorite shower, different from a meteor shower. Okay, meteorite showers are not visible, and they almost never come from meteor showers. Okay, the visible meteor showers, they almost never survive to make it to the surface. Meteorite showers come, like I said, from a larger meteor breaking up and then hitting the surface. The landing pattern of these is actually pretty predictable. Okay, once a meteor breaks up, the larger pieces will fall, and then the smaller the pieces are, the farther they'll go, and so they end up kind of in following the path of the meteor. You get this kind of elliptical pattern on the ground. So if you find one piece and you find another piece, you can kind of keep following that curved path and find more and more of these meteorites. Meteorites that we have found can all be kind of classified into three categories: either stony, so largely quartzite and silica materials. There's irons, largely metallic, nickel iron, just like the core of the Earth, and stony irons, so a combination of the two, where they are all mixed together. Percentages of these that survive to make it to the surface, almost all of them are stones. Okay, very few are iron in nature, and even fewer than that are these stony irons, the mix. And you can kind of see, if you look at these percentages, we've got these are just the ones that have been found. Okay, so a lot of them that fall aren't necessarily found. This third column, I'm not going to talk about it very much, but a lot of meteorites can be found in the Arctic. Okay, because they get preserved in the ice, and then they kind of get gathered together by the movement of the ice and the freezing and thawing. And so a lot of our meteorite finds are in the Antarctic. Okay, but they do happen everywhere. There's meteorites all over the Earth, and sometimes you can predict where they're going to be based on if you can see the fireball of a meteor falling. Sometimes you can kind of predict where you might find some meteorites, either from a single meteor or from a meteorite shower where it breaks apart. One last thing we need to talk about is the difference between these primitive meteorites and differentiated meteorites. So primitive meteorites are just ones that they didn't go through the process of kind of getting separated out in a larger body like a planet. So they're just they've never been part of a larger celestial body. Okay, they've never been part of a planet, never been part of a star. So examining these, they're kind of more mixed together, and give us a pretty good idea of what the material was like before the formation of the solar system. Whereas differentiated meteorites, they come from a larger body, like a planet or a large asteroid that has gone through molten phases, and so the denser materials settle down to the core, and then just like with Earth, you get um, less dense materials as you move towards the surface. Examining these, we can get a pretty good idea of um, what is in the Earth, okay, without actually seeing it. We can examine some of these meteorites, and like the nickel iron ones, we've been able to say that the core of the Earth is going to be the same material as the nickel iron in these meteorites that we found. And then the stony irons, they come from the area between the core and the mantle, kind of where the boundary is. So they're, again, like we saw in the table, they're fairly rare. And then stones from the mantle and the crust. Depending on where it was in the mantle and crust, we get the denser or less dense stones. Okay, so examining meteorites, we can tell a lot about what other planets are made of, what comets are made of, what asteroids are made of, and we can use all of that to kind of deduce what the Earth must be made of. Thanks.